Hello and welcome. Today we're going to be looking at types of building foundations. We'll be taking a look at the most commonly used foundations, reviewing when each may be appropriate, and what are some of the key advantages and disadvantages of each. My name is Richard and we're Quatrefoils Limited. Just an initial point worth mentioning, the video presentations we cover in this series are intended to provide an overview of each topic, focusing on the fundamentals, and will generally provide an introduction to each subject. We would advise further research and reading should you need to learn any of these topics in more detail. Now, let's get started. So, let's get started with a definition. What are foundations? Well, in short, foundations are there to provide support for buildings and structures in order to transfer the load of a structure to the ground, soil or rock beneath, that have sufficient bearing capacity and suitable settlement attributes to support them. In simple English, the foundations will sit on ground solid enough to take the weight of the structure without any serious movement. So in this presentation, we'll cover the following. First, the basic types of foundations, some useful terminology for you, and a brief overview of the soil types. Next, we'll take a look at the history of foundations, looking at some of the types of foundation in older buildings. Then we'll cover the different types of shallow foundations. These include trench or strip foundations, raft foundations, and individual pad foundations. Finally, we'll look at deep foundations, which are generally piled foundations. Okay, some basic terminology for you. The first one here, bearing pressure. This relates to the pressure on the soil which is caused by the building or structure, which is often referred to as the load. The next one along there is bearing capacity. This is the load which the ground or supporting element can carry. Subsidence, the third one along. This is the downward movement of the ground caused by the imposition of internal forces. For example, if there was a leaking water pipe, the water would consolidate the bearing capacity of the soil and thus cause a downward movement in the ground because of the weight of the building or structure. The fourth one along is settlement. This is the downward movement of the ground, usually caused by the weight applied by the building or structure itself. For example, where inadequate foundations are used, the weight of the building will cause the downward movement of the ground. Click the link provided for a further video explanation on the difference between subsidence and settlement. Last on our list here is consolidation. This is the process in which the volume of the soil decreases due to the expulsion of water and air under self-weight and external loadings. Okay, now let's have a look at the different soil types. So there are different types of soil. Some of the strongest include granite, limestone and sandstone, and then we have compact sands and gravels which provide good support but are easier to excavate. Next we have firm and stiff clays, and sandy clays which can be excavated by hand or machine. These may require wider or deeper foundations depending upon the exact build-up and bearing capacity. Last we have loose sands, soft silt or very soft clays. These are very easy to excavate but are likely to require specialist engineered designed foundations. A quick look at the history of foundations. In 1875, the Public Health Act was introduced, requiring authorities to create bylaws to ensure houses and buildings were structurally stable. In 1878, the Act was updated and included more detail with regard to the design of foundations and walls. The London Building Act was brought in 1894, which was further amended in 1984. It showed designs and guidance for foundations and walls. You can see from the diagrams below, in the 18th century, buildings, mainly houses, had little or no foundations and may have just consisted of brickwork built directly onto the ground. Later on, this was a stepped brick foundation. In the 1890s to 1930s, they developed a shallow concrete foundation beneath the brick walls. And then from the mid to late 1930s onwards, the concrete foundation beneath walls continued, but was wider and deeper, taking into account the developing cavity brick walls. Strip or trench foundations or footings are a typical type of shallow foundation. They're usually laid to provide a continuous strip of support beneath the load-bearing element, for example the walls. This is usually linear and level, although it can also be stepped to suit wall and ground conditions. The wall or structure is typically centrally loaded onto the strip foundation, although it can be eccentrically loaded, as shown in the diagram on the bottom right. This type of foundation is a common type of foundation used within the UK and is installed on many extensions or new buildings with limited stories on ground with a decent bearing capacity. So strip or trench foundations can be used in most soil types, but are generally best suited to compact sands and gravels with a good bearing capacity. In some instances where the good soil is deep in the ground, say over a couple of metres down below a weaker top surface, this option might not be the best choice for foundation, both in terms of cost and physical practicality to dig a deep trench. An alternative here might be the use of micro piles, for example. Where there is a localised single point load, say from a steel column, a larger mass concrete pad foundation might be better suited, and this is covered a bit later. In addition, if the ground conditions are poor and settlement is a possibility, a raft foundation can be used. If the building or structure is not tied to an existing building or adjacent structure, this is a good option. If it is, you can end up with differential settlement, so you might have to look elsewhere. Lastly, the building regulations cover guidance for strip foundations under approved document A, which is well worth reading. Now on to individual footings, also known as pad foundations. These are another form of shallow foundation. They can be installed to a deep depth if necessary, depending upon ground conditions. They're usually rectangular or square and form a cube-type shape, commonly used to support single-point loads, for example a vertical steel column. So what should you consider with a pad foundation? Well, they usually have a uniform thickness, although like trench foundations can be stepped, although because of their size and focus on a particular area where load is implied, stepping of pad foundations is uncommon. The size of the pad foundation will depend upon the load and the ground conditions. They can also be reinforced, commonly with galvanised steel bars or a mesh reinforcement. Because of their size, there's usually less spoil and ground to excavate. Now on to raft foundations. These are just another form of shallow foundation that can often span a wide area, usually the entire footprint of the building or structure. The depth of the raft is usually less than the depth of a trench or strip foundation. They can be a useful method where there are independent buildings or structures, such as a garden outbuilding or garage where there's a risk of settlement, as the building can move as one whole unit, reducing the risk of differential cracking arising. Raft foundations tend to have thickened areas where there is a single point load, for example around the external walls, and it can also project beyond the line of the external wall or load-bearing element, creating a toe as shown on the adjacent diagram. Raft foundations can typically be 150 to 350 mm thick, depending upon the size of the structure above. The foundations often have steel reinforcing bars and or mesh reinforcement set within them for additional support. It can also be an option in situations where there are many individual point loads, so instead of constructing a series of pad foundations, it may just be quicker and easier to install a continuous raft foundation over the whole site. Raft foundations often form the base of the floor construction, where insulation and a concrete floor or suspended floor are laid on top of these. So we've provided here an overview of the different types of raft foundations. The first here, being the most common, is just the basic solid raft slab. Next we've got a slab and beam raft. This method is used where there's an unequal distribution of load, for example from columns. The third one down is a cellular raft foundation. These tend to consist of two or more slabs with two-way interlocking ground beams, the top and bottom slabs usually connected with I-sections in between. Lastly, at the bottom right of the page, we have a piled raft foundation. The raft itself acts similarly to a ground beam to transfer the load to less compressible substrata. This would be classed as a deep foundation. So, having mentioned deep foundations, let's go on and have a look at these. There's a few common types. Most common would be piled, mini-piled or pile walls. Other methods would include diaphragm walls, caissons, compensated foundations or ground anchors. For the purposes of this presentation we won't go into any great detail about these methods, but we'll look at the piled and mini-piled ones. So, piled foundations are a form of deep foundation typically used where the bearing capacity of the soil is low, and any of the shallow foundation methods covered above aren't really suitable. So the aim is basically to transfer the load deep down into the ground to reach a less compressible strata to avoid potential movement of the weaker, more compressible soil. This is usually achieved by either driving piles, boring them, or screwing them into the ground to the required depth. They're usually formed by long, slender, vertical columns, typically made of steel or reinforced concrete. In technical terms, a foundation can be described and referred to as piled where its depth is more than 3 times its breadth. Well, that's it from us this week. We hope you enjoyed the introduction into the different types of foundations. I appreciate it was rather a whipstock tour, and there's a lot more reading you really need to do, and I'd recommend you carry this out to develop your knowledge and understanding of these topics in more detail. We've provided a few references down the bottom of this sheet for you to look into. If you've got any questions or simply want to get in touch, please contact us through quatrefoils.co.uk. Lastly, if you'd like a CPD certificate for watching this presentation, please get in contact again and we'll arrange this for you. Thank you for watching, and see you next time. Goodbye.